Okay, ladies and gentlemen, let's continue to the question. So let's go through the question number 5. If the field of vision of a satellite station on the Earth is 60 degrees, and a satellite is to be in the field of vision for 6 hours per day. This means that the 60 degree, okay, so the view of the vision is 60 degree. So it in our vision is in the period of 6 hours per day. So what is the angular velocity of the satellite? So that we should, the information given should be like that. That means that this is the vision, let's say, the vision. So its time taken for the satellite to move is equal to 6 hours per day. One day, that's in one day, one revolution. So that means that this will be 60 degrees of the Earth. So what should be the satellite move so that it will be in the range of 60 degrees, which the time taken is 6 hours. Let's move through the words found. Okay, for question number 5. 1. Let's say the relative angular velocity. Relative angular velocity of the satellite. So it will be equal to the angle. Angle is pi over 6, right? Divide by the time taken is 6 hours. Okay. Divide by the time is equal to 6 hours. That means that it will be equal to 0.0873 radian per hour in hour. Okay, so if you wish to change to the time, that means that change to second, that means that we need to convert to the 6 hour into second. But here we use hour, we do. And the angular velocity of the Earth one revolution is equal to 2 pi, and its time, one revolution use how many hours? It used 24 hours. So here we get that the Earth will rotate with an angular speed of 0.262 radian per hour. Ladies and gentlemen, therefore, the angular velocity of the satellite should be equal to the product equal to the product, that means 0.262 plus with 0.0873. So that means that it will be equal to 0.349 radian per hour. Okay, so from here, what is meant by the words of the relative velocity? We look at here, we have the here. They said that relative angular velocity of the satellite through the Earth. That means that this is the difference angular velocity between the satellite and the Earth. That means that they said that the omega of the angular velocity of satellite minus the angular velocity of the Earth will be equal to 0.0873 radian per hour, for example. So that means that actually, as we know that if this is the Earth and this will be the satellite move with greater radius, right? Greater distance. This means that the satellite should be travel faster than the Earth. So the speed of the satellite, the angular velocity of the satellite minus the angular velocity of the Earth will be equal to 0.0873 radian per hour. So what is the satellite's angular velocity? It will be equal to 0.0873 plus with the angular velocity of the Earth. So it will be equal to the angular velocity of the satellite. Okay. So that is why the yes.
How to get pi per 6?
Pi per 6. Okay. So 360 degree is equal to 2 pi. Correct? One revolution with 360 degree. So pi is equal to 180 degree. So 60 degree is equal to how much? That means equal, sorry, did 60% pula. 60 degree is equal to 180 degree over 3, correct or not? Okay, so that means that here 60 degree will be equal to, okay, let me see. The angular velocity should be pi over 3. 60 degree is equal to pi over 3. Therefore, the angular velocity should be 2 pi over 6 or pi over 3. If pi over 3, let me see my calculation. Okay, so this one should be pi over 3 over 6. (0.17). So this means that, sorry, this one should be pi over 3. Pi over 3 will be the angle divided by the time taken. Okay. So it will be equal to pi over 3 over 6 hours. So 0.1745. 0.1745. Okay, 0.1745 and 0.262. So it will be equal to 0.437 radian per hour. So, okay, question from Yongwei. What is the meaning of the field of vision? Let's say this is the Earth. We are on the Earth. This means that the satellite will move around the revolving the Earth. What we can view, let's say, we can view from this point is the range like that. For example, when the satellite move from this part to this part, this will be the vision of view. Bidang yang kita boleh lihat. Vision of view is equal to 60 degree. So 60 degree means, well, this in the field, what is the field of the vision? That means that it's 60 degree. How wide is it? The distance depends on the R. But if we mention in angle, that means that it will be 60 degree. Okay, for the question 2. Hence, calculate the distance of the satellite from the Earth. That means now we need to find the R. We know that this satellite moves with a angular velocity of 0.437. 0.437 radian per hour. So what will be the hash? From here, we use the formula. Angular centripetal force, where Fc is equal to the Fg, gravitational attraction, gravitational force. mv squared over r will be equal to g m mass of the Earth, mass of the satellite over the distance of the r. Okay, so as we know that the mv squared over r, v squared, v is equal to r omega, where we need to convert it m r squared omega squared over r is equal to g m e. Okay, ms over r squared. Don't forget the square. Okay, ladies and gentlemen, from here, r omega squared, that means that we can mention, we can use the formula. What is gm? Gme actually is equal to g r squared, right? So replace into the formula where I get that. This r squared will become r. So gme will be the gr squared. So from here, mr squared omega squared over r, that means that it will be mr omega squared will be equal to gme is equal to gr squared. Okay, r is the radius of the Earth times with the mass of the satellite over the r square. So we get that the R3 will be equal to, this is the M will be the M satellite. M satellite can be cancel each other. So at the end, we get that G R square over how much? Over the omega square. So from here, R cube is equal to G is equal to 9.81 times with the radius of the earth will be 6.3 at times 10 the power 6 square over the distance. Sorry, over the angular velocity. So angular velocity of the satellite is equal to 0.437. That means that it will be 0.437 radian per second, right? So just now we get that it is 0.437 radian per hour, per 1 hour. We need to convert it into how many radian per second. So if radian per second, that means it will be 0.437. 1 hour is equal to 3600 seconds. So that means that this we need to divide by 3600 seconds. So equal to how much? So from the calculation, 9.81 times with 6.38. The power 6. Okay, so square. Divide by so that means that R cube is equal to let me see how come become okay. R cube is equal to 3.2 at 95 times 10 the power 18. So at the end, I get that R is equal to 1.4 at 7 times 10 the power 1, 2, 3, 4, 5, 6. The power 6 meter. Okay, so this means R will be the height. R will be the distance of the satellite. From the R consider is from the center of the earth, yeah. So as a result, okay, the distance so the distance will be 1.4 at 7 times 10 to the power 6 meter. Okay, so let's move to the question number 6. Two satellites of the Earth have the same radius but with different mass. Okay, same radius with different mass, and show the both of the satellite move with the same velocity around the Earth. So this means that from here, we still use the formula. Okay, let's go to the Earth. Words. For question number 6, by using the Fc equal to Fg, centripetal force equal to the gravitational force, mv squared over r will be equal to gm e m, that means m for the m satellite, over r squared. So from here, what we get it, ms can be cancel each other. That means that r also can be cancelled at the end. The speed of the the square speed of the satellite is equal to g m e over the distance from the center of the Earth. So v, speed of the satellite, will be equal to square root of g m e over the r. So prove that the velocity of the orbit is independent of the mass of the satellite. That means that the speed is not depends on the mass of the satellite, but it depends on the mass of the Earth. Mass of the Earth we cannot change. The gravitation constant g will not change anymore. Just the r will be different. The speed of the satellite depends on the distance of the satellite from the center of the Earth. So v, from here, v just will be inversely proportional to the square root of the r. So speed of the satellite or velocity of the satellite depends on the r, but not depends on the mass of the satellite. No matter how big or how small are the satellite with the same distance from the Earth, they need to move with they will move with the same velocity. Okay, question number 7. Let's move to question number 7. One Earth years is the time taken for the Earth to complete one orbit around the Sun. Hey, what is meant by the meaning of one Earth year? From here, as we know that, we look at here, yeah? V is equal to S over T, correct or not? Okay, so how about 1 Earth years is the time taken. So time is equal to S over V. It's a time taken to complete one orbit of the sun. So the average distance of the Earth from the sun is 1.496 times 10 to the power 8 kilometer. And the average distance of Neptune from the sun is 4.497 times 10 to the power 9 kilometer. Express 1 Neptune years in terms of the Earth years. So we need to compare. So now let's go through the question. Question number 7. From here, for the Earth, FC is equal to FG, where mass, this is the sun, let's say, and this will be the Earth. So M, mass of the Earth, V square over R will be equal to G, mass of the sun, mass of the Earth over R square. Okay, so it will be equal to how much? So as we know that okay, let's say this is the equation 1. Equation 2, 1 revolution, the distance. Period time taken for 1 revolution is equal to 2 pi r over the v. Okay, the speed. So this will be the equation number 2. From equation 1, we get that v will be equal to square root of g m of the sun over the radius. Okay, as a result, let's say this is equation 3. Substitute equation 3 into equation 2, sorry. So from here, the time taken for 1 complete revolution will be equal to 2 pi times with r. 2 pi r over square root of g m sun over r. Then we solve the question. This will be t equal to, okay, if I make it square, t square equal to 4 pi square r square over g m sun over r. So this we get that t square equal to 4 pi square r cubed over g m sun. Okay. So now the time for the time taken, the period taken for the Earth's square will be equal to 4 pi square over g m sun times with the radius of the Earth, distance of the Earth, center of the Earth to the center of the sun. Okay, let's say this is the equation number 4. Okay, for the net turn. T net turn square will be equal to 4 pi square over G M sun times with the R of the net turn cube as well. So this will be equation number 5. Let's say if we use the formula equation 4 over equation 5, where we get that T at square over T net turn square, it will be equal to how much? G, 4 pi square. M sun times with R E square divide by 4 pi square divide by G M sun R Neptune cube. Okay, this is a 3. So at the end we get that T at over T Neptune, the power 2 will be equal to R E over R N cube. As a result, TE over TN square will be equal to the distance of the, okay, so T E over T N square will be equal to 149. 1.74 times 10 to the power 6. RE over RN. Wow, yeah. What is the RE? Okay, 9 and 10. 1.496 times 10 the power 8. And also 4.497 times 10 the power 9 kilometer. Okay. So at the end, T E over T N will be equal to